Hey, sorry for the late start. Time slipped away from me today, but yeah, welcome to the 16th week of our game dev streams. And today we are going to look at biome mapping. This is a pretty cool area of things, and at the moment, so far, our caves have been, our maps have been mostly sort of just carving out the shape, which is all well and good, but we're going to have to eventually put something in to this. So part of that will be biome mapping. So we'll sort of carve off different sections of the map to be different biomes, and then those will have their own generation within them of sort of the tiles and things that come with that. So what I've been working on just before the stream, so I defined a list of biomes. These mostly at random, of things that I thought would make for good overworld and sort of interior biomes. I've defined a palette for each of those. So we've got different colors for each. I've defined a grayscale palette as well that will range from white through to black. And these will become evident in their usage later. And then what I've been looking at just now is, can we generate some noise, which is how we are going to mostly make this biome stuff work. So first off, no, that was me messing up my languages again. Where is that? That was in here. Okay, let's try and get the boilerplate. I was trying to get the boilerplate in place first. Okay, well, it's rendering something, not quite what we were after, but it'll do. We can work from this. So this is going to be a noise biome map. So what we're going to do is, if you remember before, we looked at simplex noise, and this generates some interesting shapes, but it wasn't particularly very useful for us in our cave generation attempt. So we're going to come back to that now, though, and we're going to use it in a slightly different way, which will hopefully give us a more interesting layout. So we update. So I've created this to map method. Which should align the value. So if that is, which should align each of the values to map up with a value within the palette. So this means we can convert a 0 to 1 sort of floating point map into tiles, into whole numbers. So if we want to go from 0 to 255 for our grayscale palette, let's Let's see what we're actually getting coming out of. Okay, so we have, so that is rendering correctly. The question is, why is it then not rendering if we pass the palette? So this should be generating let's have a look at what the palette looks like. Yeah, so that's generating a smooth flow of colors because the palette is the red, the green, and the blue, followed by, for each color, followed by the next, and the next, and the next, and so on. So that appears to be correct. So our render method takes the palette. This is what I was trying to get working for us before we started. Palette is then passed to render data, and that palette is then used for the image. So why is this not mapping onto what we set? Yeah, so we just update the data normally. This is definitely set correctly. What happens if we scale this differently? No, so it's not a problem of the values overrunning. Let's see if we can debug this. Sorry, I was trying to get all of this done before we started stream so that we could start and dig straight into some of the algorithms, but it looks like we are going to start by debugging. That is interesting. Why is this outputs numpy values? So so that maps, it looks like we're mapping things correctly. I'm just not sure why the palette isn't being picked up. here. Okay, let's try and debug this a bit more. So we can define an image. See how that works. We define our palette. Bugs straight out of the bugs and problems straight out of the gate today. This is I was hoping this one would be a nice fun one we could jump straight into, but it turns out that is not to be. Okay, so we've got our it's because this needs to be the way around. What do we normally do? We could create bytes from that. Okay, let's okay, so this is drawing. So it draws when we do it directly. It's just somewhere in our other code things are going wrong. So let's do something really hacky for now, and we will take our render data method and we're just going to redefine it here while we work on it. Okay, so this is not going quite to plan. So if we render this, okay, so we get an empty image here. So if we define the palette is there. Interesting, because this is exactly what we did in the function. And it worked fine. What did we put? Yeah, so when we define this here, hang on. Yeah, that's messing up. So what do we get when we look at the data that's passed in here? When we look at the data, okay, so we're getting zeros. So somewhere we are losing. Hi Splash, welcome in. Today we're looking at biome, defining some biomes for our maps, but we appear to have broken things right out the bat. I was trying to get some basic code in to draw things before I started, but it turned out none of that actually worked when I tried to run it. Okay, so what do we have? Okay. So that is our problem. So far we've just been updating the data, but we haven't actually, but we were rendering out the original array, not the one from the context that we assigned it to. So that meant that when we rendered the map, it was using the original one, and in any generator that completely replaced the map, it was going to fail. It just so happened that we haven't done that until now. So now if we run, hey, we see a nice noisy image, which is what we're after. Been playing around with sprinkle stuff all morning. For hooking things into your Streambot. How does Stream Elements do that? Does it give you like a little basic scripting thing to code them in, or is it like something you have to do from a fixed list of supported features? Okay, here we go. So yeah, so now in our map we've generated some noise. So yeah, so this is our starting point, and where we're going to start with our biome generation, in that the simplex noise gives us a pattern. So if we take this to its absolute most basic thing, okay, yeah. So what we get is a effectively random static to begin with. The special thing about simplex noise though is it's a gradient noise, so the values next to each other are quite similar, even though there's randomness here. So when we scale the noise, and I believe the technical term for this is frequency. So let's say we can times each of these values by the frequency, and we get something a bit more zoomed out. And then depending on what we set as frequency, we'll get slightly smoother or less smooth noise. And therefore, when we lower the frequency, and we go and we set it to 0.2, we get more randomness, more coarseness to it. And then when we lower it, so if we go back to 1, for instance, it gets smoother, and if we go to 0.1, it gets even smoother. So this one we can see it's a gradient of values very clearly. Somewhere in the middle of those last two. Yeah, so this is how we're going to start to build things up. So we've got our noise. The trouble is it's a bit too smooth, so we want to make it a bit more random, and for that we want to use something called fractal Brownian motion. Oh. Okay. Yeah, that's actually filled it in a bit too much for us. We wanna work through this slowly. Though Copilot looked as if it was actually on target there. Okay, so we're gonna want. So what we're gonna do is we're gonna have we're going to layer on several variations of the noise in different octaves, and that means we're going to take, for each point, we're going to take several different frequencies and combine them, which should give us a more interesting output. So to do this, we are going to want total, frequency, and then for to look this up again. Let's put some lights on for a start. Let's have a look at the definition again. We want so we've got, here we go. So we've got fractal Brownian noise. So we've got the frequency. Here we go. So we have the octaves, the chronicity, which is the amount by which, the factor by which this frequency changes each time, amplitude and frequency. So if we switch back to our code, we have a value of 0. So amplitude and frequency. And then for each of the octaves, we set the noise value to we add the noise. And then we times it by the amplitude. There we go. And then max amplitude is we add the amplitude. We also need a value for persistence. We then do amplitude is times by the persistence, and the frequency, and then we want our lucrosity value, which is 2.0. And then we multiply the frequency by the lucrosity. I think we return the value divided by the max amplitude. Okay, so this way we're going to layer up each of the spelling. No, that is actually a word. It's just a really random, rare word that's only used, Latin word that's only used in weird maths geometry. Okay, so what we're doing here is we're layering on, as I said, we're layering on the different values of the frequency. So we are for each round, we're adding the value of with our amplitude, and then we are halving. We're basically then reducing that each time. So each value is going to contribute less and less, and the frequency is going to get smaller and smaller. So that should be 0. No, sorry, the frequency is going to get higher and higher, but the way that contributes to things is going to get smaller and smaller. So for each round, our frequency, we will look at an ever more zoomed in version. So in theory, we will take something like this, and then we will layer on. Well, we'll take something like this, and then we'll layer on. So doubling that to 2. and we'll add this on, but only half the value. And then we'll go to 4, and we'll get like this, but that'll be only a quarter of the value of this will get added. And we'll keep going, adding, and then this, but this, then even less will be contributed. I think that's how I understood it was going to work anyway. So now, I want this to be a float. So now we should be able to go FBM, the generator, X and Y, and we want our octaves to be 4. And if we generate that, okay, that's not what I was expecting. I think I've assigned these wrong. Let's set the frequency to 0.1. See what we get. There we go. So now we've got something a bit more complex and interesting. We should pass some of these values in as well. So we want we'll pass in frequency and persistence and lacrinosity. So now we should be able to tweak this from here, so we can go so we set low frequency. Okay, we get a very we get quite a nice little smoke effect there actually. But we're not quite good for our terrain. We want to go somewhere a bit more interesting. What happens if we change the octaves? Okay, that busies it up a bit more. Or we go really low. Okay, so that looks if we actually take out the achromosity of it? Okay, so that simplifies. The frequency changes is where we get the randomness, but this is hoping for more of a scale. Alright, well, I guess we can start. We can start here, I think. This is enough to get us going. So let's actually have a look at the values we get out of this. Okay, so we have a look at the data itself. So our values are all actually quite low. I guess that could be to do with the I'm sorry, let me, okay, we're gonna have to work through this and see if we can get figure out where it's going to score with. So I think so I think what we probably want to do next is we want to got those the wrong way around for a start. That's never good. Okay, so we want to set the x and y values, and we're going to want to do data.xy minus divided by minus the minimum value, so that will make our lowest value 0, divided by the max value minus the min value. that should give us a value ranging between 0 and 1. So then if we run again, double check that. Okay, so 0 to 1. There we go. Okay, so now we've got our data mapped to a specific range. So, okay, so I think what we actually want here is a normalize function, which we can use in various places. So let's come back up to where we first do this, which is in our to map. So for this we want to have data float map. Data, value for each, and then we want to return we want to return value I'm going to do value minus min data. So that normalizes it back to 0 divided by max data minus min data for value in row. For row and data. Yeah, so that should normalize the float, and then in this one we can then go this is not the most efficient way of doing it, as we're looping over it twice, but value this is not the most efficient way of doing it, as we're looping over the same data twice, but we do get to reuse we do get to reuse the function, which is handy. So normalize the values. And that turns it into a map. So we'll take our normalize values function down here, where we were using it, and once we've got that, we will normalize the values, and then we can skip over all of this. Okay. So now we've got, what did I call it? So we should be able to render this out now. Here we go. That's looking better. So as we run this, we're getting a nice sort of yeah, we're getting a nice randomly drawn image. And what we're going to do is we're going to use this to decide we're basically going to use this as this along with some other values to create a terrain based on some rules. So So we're going to return. So we're going to generate. Yeah. So this is going to be our height map, and we're going to then use that to decide how high the terrain is in that area. So we're going to assign the values to that, then we'll normalize it. And data, yeah, so for every point on the map, we're going to run our no, that doesn't work, sorry. data into things. So, so now actually I want the biome. Biome palette. So why is this generating all zeros? That should not be a thing, right? Okay, hang on. It's because I'm returning. Oh. I messed up here. I don't actually need to normalize this because it's actually formed properly. So this is actual values rather than floating points. Okay, so we've got a nice order there, but we can define some rules. So we're going to define some rules around how we allocate biomes. So I'm going to say if the height is greater than 0.7, then we're going to return by the mountains. Oh, sorry, mountain. If the height is let's go the other way actually. Hang on, sorry. Yeah. If height is less than 0.3, then we're going to say it's an ocean. If it's less than 0.4, we say it's beach. Let's go for 6. We're going to say let's go for plains, and if then if else we're going to return. We're going to return mountain. So then if we run this function, we get something more akin to terrain. I think the mountains are a bit too, I think we could transition to mountain a bit too quickly though. So I think, actually, let's move this out as well, because we're going to want to specify this on a This is a callable, and we're going to pass in integer, pass in a float, get an integer back. Define our function outside and we'll pass that as a parameter. So then we can customize it each time. It also means when we're editing it, we'll be closer to the code. So let's move our mountains up a bit. So we want to say the mountains come a bit further up the scale. Okay, so we've got a lot less mountain now. Would we even take that to 0.8? No. Okay, so I think that's good. We want to try and mix stuff into this as well. So the beaches are a bit too big though as well. So let's change that to 0.35. Okay, should get smaller beaches now. Okay. Then if height is less than 0.5, we'll return plains, and then forest for slightly higher than that. Oh, okay. Hi Crumbs, welcome in. So yeah, okay. So now we're starting to get some actual terrain out of this. We could also go. I don't really have a biome for the very top for snowy mountains, but go 6 for that. If height is less than 0.8, then we go for tiger, which is my understanding is a snowy forest. Ooh. Okay. We're getting something. We are getting something here. This. It's a little bit hit and miss at times, though. Let's try and generate islands. I think islands will be cooler to look at. So we could. Well, okay, so for that. For that, we want to calculate the distance to an edge, and then bias the value to be lower. So we're going to want a factor to manipulate it by. The max distance to an edge is min of one of those two divided by 2. Actually, I don't need that. I just need to know how far it is. No, yes I do. Okay, so I want the max distance from the edge, and then distance distance is equal to the min of x, y, width minus x, and height minus x. So that's distance. What I actually want is a ratio. So divide that by max distance. That will give me a percentage of distance from an edge. And then I then from this I'm take away the bias factor times the ratio, and we want to make sure it doesn't go. You know, that should be fine, I think. No, I think actually I need to do a second pass on this. So yeah, I wanted a second pass on the value. So for each point, maybe I just want to do distance to the center. So equals okay, so the center is going to be cx is equal to constant cy, and then we want max distance is the square root of the square of cx and square of cy, which would be the distance from 0, 0 to that. That will give me the max distance. Okay, so then distance from the center will be cx minus cy times 2, then we want we're going to want a ratio which is that divided by the max distance. height map yx is equal to minus yeah, I think that's correct. So we want to set it to the a minimum of 0, or we want to subtract the bias factor times that rate. No, that's definitely not right. Let's clear it out. I think it might be 1 divided by one minus, sorry, one minus that should give us a ratio. Sorry, no, that's the wrong way around. It should be max, not min. So we want this. We want to take the largest of the values. Okay, that's not what I was expecting to happen. Did I have it right in the first time around? No. Actually, maybe I do want. I think actually I do want distance to an edge, don't I? So hang on. All right, let's think this through. Okay. So what I want is a map that decreases in value the closer you get to the edge. So re-tackle this from the beginning. We go 0.0 for, okay, yeah, so we clear the data, get some clear data, we're going to return early so we don't execute anything under that. And we're going to return the context data, and we're going to go for a grayscale palette. so this fails if all the values are 0. Sorry, if all the values are the same. So that should fix it. Okay, so we want to map the distance out from the center. So for x, y in so we want to, set our center. And we set our max distance. I forgot we already had a helper for this. And then for each of these, we set it to that. Yeah, okay, so we get, no, that's the opposite of what we want. So we want 1 minus that value, and that will mean that we get more value in the middle, and as we go out, we decrease. Okay, but we also want to make sure that as we get towards an edge, that we want to make sure that we bias it towards the edges, not towards the corner. So we want to go for the smallest of those two values. And our spear should touch the edges there. No, still. But it is close enough, I think. So we've got what we want is to take we don't need the data, and then we want to loop over our normalized height map and do that is equal to the min of, sorry, that is the max of 0 or ratio. Yeah. We want to minus the ratio times bias factor. So it's 0.1 for now. Actually, let's take the bias out completely for now. What happens if we set the height map to the ratio? So what we want is to get a weird round shape. It's still coming out at zeros. What have I broken? It's the palette, isn't it? I switched this and forgot to switch it back. Okay. And then when we introduce our biasing, we should now start to see islands. Islands, come on. No, the opposite of an island. Okay, so I did have this right in the first place, that it is that way around. Okay, so now we now have islands. We're not actually getting the height up into the mountains anymore. Oh, that one didn't generate anything. So I think so we need to put this bias factor back in. So we want the influence that's currently from the edge dropping bit is too strong. So 0.1 is not high enough. 0.4. Okay, so we've got our ratio there. What if we just plot the ratio? So I think what we want to do is stretch out, manipulate this ratio to give us a less influence in the middle, but more in the center. we take the distance, what happens if we make this bit a bit bigger? Okay, so that does push the edges out a bit too much. I'm trying to remember my maths now. Is it what if we do log 10 of? No. We want to convert this into an exponential. We want to so we've got the max distance. We've got so we're going to calculate distance. Then I think we want to my brain is not mathsing today. So the ratio is the max divided by the distance, and then we want to go something like that. Oh, the distance is ratio. Sorry, ratio is 0. It's less than 5 else. So if we start the decline further out, we now have cutoff. So then if we go 7.5, 7.5, and 7.5. So we get to here, and then what we want is to work out where that point is relative to the center. Is it like that? The math, yeah, cool. Yeah, the maths is not mathsing well today. So by doing this, we're introducing a cutoff that we only want to affect things that are greater than 3/4 of the distance to the edge, and then we want to steeply descend into water at that point. So then I should be able to do something like this. No. Times the bias factor. Oh yeah, that's creating all kinds of issues. Okay, so I think we just want to fiddle with the bias factor then to get it. I mean, we're doing okay, I guess, here. I think for now, actually, I'm going to take this piece out. Oh. Sorry, my door creaked itself open. Actually, I think I'll take this out and we'll look at something more interesting for now, and I'll have to have a play and figure this out a bit better before we come back to this. Okay, so we've got mountains, we've got taiga, forest, and see, I think what we can do is if we take that out and go to 7 on the forest. All right, we've got so we have a map here for the height. What we also can do is have a moisture. We create a moisture map. What we do is, as we're populating the height map, we also populate this moisture map. and we want to generate this slightly differently. So we could offset it. Slightly, and then we can pass into that function a moisture float, and then for each value here we're going to pass the height map value and the moisture map value. So we now have two values to play with when we're selecting our biome. So I think we'll keep those the same. Then if the if this is moisture is less than 5, then we'll go say it's a desert. If moisture is less than 7, then oh, then we'll say it's a savanna. No. So if it's less than 4, we'll say it's a desert. If it's less than 6, we'll say it's a plains. Yeah, we'll say savanna for that. If it's less than 8, yeah, 4, less than 4 for a desert, less than 6 for a savanna. Otherwise, we'll say it is plains. So now when we run this again, we should see a slightly more interesting setup. Oh, sorry, we have a dot there instead of a comma. Let's fix that and run again. Okay. I think we need let's render out the maps as well so we can see them. Both of these need the grayscale. So I fear that I might actually have the desert set too high. say less than 2 for a desert, less than 5 for a savanna, and then the rest can be plains. There we go, we're getting a much more sensible mix now. Hang on. We are not normalizing our moisture map. Let's make sure we do that. That would explain why the values are so off. Here we go. So we want to go have a look at our biomappings. Maybe the desert needs to go up a bit more. Now we're getting a bit more variety. So we've got some desert around here, we've got some plains, some savanna, more desert. Alright, and for our forest, we want to go dry, we'll have a tiger. And then if the moisture is high, then we will return jungle. Okay, so we're getting far more diversity into things now. Actually, let's go forest. Return jungle, and if the biome is wet, then we'll go for a swamp. And then we'll go for the mountainsides. As we get higher, we'll go for tiger, I think. So we're starting to get more diversity into our map. Yeah, so we've got our beaches, savannas and plains. We've got some forests and jungles. So we see there's a real dry streak through here, which so so we've got a shallow strike through here which turns into this water. Got a dry streak down the bottom here, which should give us temperate biomes here. So we've got desert along here, but then where it's more wet, we've got jungles and forests. And then we've got a bit more moisture down here in the mountains, which gives us some taiga here. The other thing we can model is we could also model temperature. So we'll map our temperature map, and then we'll put that in here as well. We'll offset that by 200. Sorry, 2000. It'll give us a. So the offset here just means that we make sure that each of these maps is different. And we also want to map our temperature map. Then we want to feed that in as a third parameter here. Mark this as taking a third float. So actually we can move that out and say if for forest area, if the temperature is less than 4, then we'll have a tiger. For our plains, if temperature is less than 4, then we'll have a tundra. So we've got height, moisture, and temperature. Okay, so we've got colder areas over here, which is giving us tundra. Next to savanna. I think we probably want to play the mountain down a bit more as well. Let's go for under 8. Then we'll have a forest. That should mean we get far less rocky areas, because we don't really want the rocky areas in our final maps, as we don't have much in the way of being able to generate the height. Okay, this is interesting. So I believe this is the tiger here. So we have the desert, desert next to so I think we probably want to say we want to restrict the desert to higher temperatures, because we don't want the desert to form right next to the tundra. Okay. We've got, yeah, we have a rogue display there that's outputting an output, but this is, this is not bad. So what we've got here is basically our different types of terrain. So we can look at the different maps that we've generated. So we've got our height map, which says that basically we've got a low area here, and the higher area is here, here. And then we've got our moisture map, which says that it's dry here and here. Got a lot of moisture over this side, and intermediate around here. And then we've got a temperature, which says that we've got coldness at the top here, a bit there. We've got some quite warmness here, average sort of around this area. And that then maps onto this as, okay, so we've got where it's cold down here, we have some tundra going into savanna, a bit more tundra here. It starts to dip down again. Then we've got taiga mostly around here. I'm not quite sure what colour that one is, but I think is that jungle or plains? I think that's plains. So yeah, we've got the savanna going into the plains. So the biomes now seem to be a bit more sensible. I think we'll need to play around with the algorithm a bit more. I probably need to do a better job with the colouring as well, to make sure that they're drawn better. But we're getting something that resembles a not too weird of like a mini map for a game. Let's take some more of the mountain out. I think we've probably got a bit too much of a bias towards mountains. Maybe we take the water down a bit as well. Okay, so now we've got the lower 2% is ocean, and so the lower 20% of the map is ocean, the upper 20 is mountain, then and then 20 to 50%, the lower. Then from 20% height to 50% height, we have our flatland, sort of our more clear biomes. So this is so that's, we're going to put our sea level, we've put sea level at about 0.15 there. A mountain is at that level, and then we've got a forest level and a low level. lowlands level. Yeah, let's call it a highland level. So what we've ended up with is, as we move up, we've got, by the water we have, we have our water, then as we move out of the water we have the lowlands biomes, which will be the taiga if it's cold, the desert if it is warm and dry, sorry, hot and dry, and then plains or savanna, depending on how moist or temperate it is. Actually, no, just depending on how moist it is. So yeah, and then for our highland areas, we have taiga, jungle, or forest, depending on, or swamp, depending on the moisture levels. I guess swamp would be a lowland biome though, wouldn't it? So I guess this needs to be evenly divided. Take that to 6. Actually, yeah, no, anything below a certain temperature is the moisture is less than 0.8, then we'll say it's plains, and else we'll say it's a swamp. And for the beach, will also should probably put a cap on the beach as well, so that we can have grass going all the way to the ocean. We'll have the tundra go all the way to the ocean as well. Okay, I think I'm happy with our biome distribution now. So for our sort of more overworld areas, this is a good start, I think. We will need to, there's a couple of knobs that we should probably play around with. One is I need to validate that this function is correct and play around with the input some more. For each of these, we want to play around with the way it's varied. So we might want to tweak the octaves and the frequencies to get more interesting values. And yeah, we'll probably want to tweak this a bit more. And we want to probably have some more of these that are biased in slightly different ways. So if we have an ice level, for instance, we probably just want to have tundra and taiga biomes. Whereas if we're going for a desert level, we probably want to have the desert and then maybe a bit of savanna in places. There's still some biomes I didn't include in here, but like the mesa. So yeah, there's a few that I didn't actually include. So we've got those. Wait, did I not define a mesa one? I thought I defined a mesa. I was obviously imagining that. What we've got here? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And here we're returning 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, yeah, so we are mapping all of our existing biomes onto there. But yeah, we could probably tweak these a bit to get a nicer distribution, but I feel like it's not bad. It's not too bad as it is. It's a good start. So I think I am going to call the stream here. Yeah, I think I will try and wrap my head around a few more techniques, a few more of the functions in this. So that I did very light research before this into what we would need, and that's got us so far. But I think I need to dive a bit more into the various parts and figure it out for next week, and then we can start to refine this even more. And then we need to figure out the code to generate an island, because I think a natural on this sort of field, I think a natural water barrier around the outside would be a much better way of generating things. So rather than having like an invisible wall here, as we would at the moment, we could potentially having a ring of ocean around the outside would make it a bit more natural. In the way we generate things, and then this, and perhaps we can even combine this with one of our other generators. So we could possibly use one of the, maybe not the symmetrical algorithms, but something less symmetrical. I mean, if we layered something like this over the other one, basically forced the wall area around the outside to be water, we might get something interesting. Yeah, so we've got this. There's a couple of other biome-based algorithms we can use. One is the Forici cells, which we can use to create biomes around rooms. So I think they'll come in more handy for our underground biomes. So for something like this, we can basically select a biome for each of the cells, and then expand that out to make sure that everything around is in one or two of the other. So that's that'll be another approach we can take with things. So there's still a bit more on biomapping left for us. But for now, I think I'll leave it here, and we can pick up some more in the next episode. Next week will be the last before taking a short gap, because I am away for a few weeks and won't be able to stream. So I think we'll have one more on the 4th, and then I will be away and we won't be able to do another game dev stream until the 25th. But so yeah, I think it's not perfect and there's still room to expand, but I think we've definitely made some progress, and it's starting to look like a map. So I will hope, if you've enjoyed the video, give it a like. If you want to see what we do next, then give the channel a subscribe, and I will see you in the next one. Bye.